Welcome back. So in this video we'll be learning about logical volume manager LVM. It's an important concept in Linux. Like, why do we use it? We use it to combine multiple disks to easily resize volumes for disk efficiency, and for performance optimization we use LVM. Basically we use LVM to manage disk management efficiently. And let's go to the implementation as well now. We'll be creating AWS EC2 instance, and we'll be adding two volumes, 25 GB, 25 GB volumes, and try to create a logical volume manager in EC2 instance. Let's go and do it. Let's create an EC2 instance now. Let's name it as server. Simple name. Let's take Ubuntu. I'll take T2 medium. This would charge a bit, so you please bear with me. So because we'll be doing experimentation now, right? So this will charge little bit. Whenever you are doing, so be careful to delete the machines after completion of the lab. I would suggest you to delete it, because it will definitely it will charge something. Some dollars it will charge for 1 hour, maybe around 0.28 some dollars something. Once it is created, so let's try to log into that system. We've logged into the system. Let's check the disks. How many disks we have? We have only one disk, that is root XVDA, that is root disk. So let's add two disks. So let's go to LVM. Let's go to volumes and try to add two disks. Create. Let's add 25 disks and 20 GB disks. This will definitely charge, so be careful when you do lab testing or anything, because this will definitely charge something. One volume is created. Let's take another volume, 20 GB. So we'll combine both in LVM. So these two volumes in LVM, and let's create it for disk purpose, like for partition of disk and all. We'll be creating using these two disks. These two disks are created. Once they are created, let's try to attach it to an instance. Once it is attached, let's check the disks. It should appear here. Yeah, it has appeared. Two disks are appeared 20 GB and 25 GB. Once these are appeared, let's create a logical volume manager. Let's try to create partitions. Try to create a partition, attach and mount those partitions to a directory. Let's do it. So for that, let's install LVM2 package manager. Sudo apt update sudo apt install. This is the package we need. So this is the package we need. So let's install that package. it should be a complete lab experimenting around a logical volume manager. So focus and try to do it along with me. That would be beneficial for you when you do it. Let's check the disk. This we got. So we have two disks attached, right? So these two disks are attached. Let's create physical volume. This is the command. Physical to check physical volume. Let's become root rather than writing again sudo. Let's become root. TVS, it will give the physical volumes. Let's create volume group now. VG create. Group name my group. Any name we can give, but I'm taking the group name as my group. And this partitions. Now this is also created. 45 GB. On this created, let's create first logical volume. Let's create first logical volume. LV create -L. Let's create 5 GB. Let's create 5 GB for now, and let's extend it to 35 GB later. Volume 1. My group name. Let's create another volume, logical volume. Let's create another logical volume, that is 2. That also let's give to 5 GB. After that, let's check the volume. Those are created, right? So those are created, they are in volume group. This is the name of the volume. So once this is done, let's format the logical volumes so that it can be used. For formatting, mkfs ext4 dev my group volume 1. Volume 2. Once they are formatted, let's try to create a directory. mnt After creating directory, let's mount the disk to these directories. Let's try to mount it. Mount dev my group volume 1 mnt volume 1. Once they are mounted, we can verify using df-h if they are mounted. Yeah, we could see these two are mounted, right? 55 GB, right? These are mounted. Once these are mounted, let's get the BLK ID and write, because if we restart the node again, this mount will be gone. So to make it persistent, we have to add UUID into FS tab. For that, let's get BLK ID. This is the BLK ID which we got. is we have to add it into fs tab. Vi etc fs tab. We have to add it here. So make it persistent, we are adding this, because even if we restart the node, the mount should not be gone. So for that we are adding it. Once they are added, let's try to apply the changes. For applying the changes, you have to use mount -a. We didn't get any error, so because we didn't get any error. So the reason is like it is applied successfully. Let's try to check the disks down now. Like we have two partitions in LVMDBB. These are the two partitions which we created. So let's increase the partition from 5 GB to 35, and let's try to see if it's getting if gets increased. Let's see. Let's check VGS. Show VGS. No. It should be not show. It should be VGS. This give the partitions. This shows the logical volumes which we have. Two volumes we have. This shows the complete volume group which we have. Like 10 GB is used. Free is 35 GB now. Let's try to add. Let's try to extend the volume of volume 1. Let's try to extend that. How do we extend it? There's a command for that. Before extending, let's zoom out it. Let's grep -h if that mount is found. Mount is not found. So let's increase it. Sudo to increase the volume, we can lvsize -l 35 GB dev my group volume 1. LV size, no, LV resize, sorry. Now LVS, if we see, is 35 GB now, but still it is not increased. Like if I see LSVLK, still I don't see any increase, like volume, like it is not yet increased. So for that, there's a command in AWS wherein we have to run that E2 fsck -f dev my group volume 1. Let's resize dev my group volume 1. Resize to fs. Okay, sorry, to fs. Now let's check if it has been mounted, and we mounted it using that command. So like let's check if it is mounted. Still we see, like, it is not been mounted yet, but we'll be mounting it now. But still we see there is no change. No, it is pointing to root directory. Let's mount it now. Mount dev. Is failing now. Let's check. I have checked that it is already mounted. It was already mounted. I checked from dmessage logs. Like we can check it from dmessage logs. Mm, It's saying it's already mounted. Let's check if it is already mounted. It is mounted, yeah. It became 33 GB. Yeah, 35 GB. It is updated to 35 GB now. To make it persistent, you have to again add, like, let's see if we have added in fs tab. Same volume we are using, same ID it is there. So anyway, we'll add it. Mounted. Let's check if all the disks are correct. Yeah, so it is 35 GB now. So the reason it is showing here and here both is because it is consuming the both disk XVDBB and XVDBC. This both disk it is consuming. That's why it is showing in both side, like 35 GB both side. Yeah, so we were able to combine the volumes into one. In two disks, from two disks we are able to combine volume into one group, in one volume group, and then create logical volume out of that one volume group. We can display the volume group also. This is the volume group, like 49 GB, 45 GB, complete 45 GB, out of which 40 GB is utilized, 5 GB and 35 GB, and 5 GB is pending. 5 GB is still to use, so we can use it. We can display LV also, logical volume also. Volume 1 will display. It is saying 35 GB and has read write. So this is the volume. This is the volume 1, and we can also display PV. We have two PVs, right? So two physical volumes, 20 GB and 25 GB. Once this is done, so our experiment is completed. Now we are able to add two disks into AWS and try to combine those two disks into logical volume group, and create a volume group. And after that, we were able to create logical volumes out of that into one. Then we have also extended the volume from 5 GB to 35 GB, 5 GB to 35 GB here. And let's try to delete the volume 1 now. Let's Before deleting, we have to unmount it. So let's unmount it. Umount. Let's see if it is there or not. Not there, right? So yeah, so let's remove LV remove. It will prompt for yes or no. We have to pass yes if we want to delete the logical volume. Once it is done, let display PV now. PV display. Like 20 GB, 25 GB. Yeah, so let's try to see if that is deleted. LSBLK. Volume is unmounted. You like unmounted and I've deleted it, so that is gone. But volume group is still there. Like volume group is still there, right? So volume group. How do we check volume group? VG display. Volume group is still there, so we need to delete that as well. We need to reduce. We cannot delete it. We have to reduce it. We'll have to remove PV also now. So let's remove PV also. LV display. We have only one disk, one partition, that is 5 GB. Volume group display, we have only one volume group, which is 25 GB. This also will delete it. Let's delete that also. For deleting that, you mount. It was not getting deleted because we are using, right? So we are using this 2, volume 2, we are using it. Successfully removed. Volume group is successfully removed. If we see, LV display, it will not be, nothing will be shown there. Nothing, because we have removed that both the volumes now. But we need to remove volume group also, right? So we need to remove volume group also, and we need to remove LSBLK. Let's remove PV. Now everything is removed. So yeah, so our lab is completed. We're able to, first we created two disks, 20 and 25 GB in AWS, and try to see if that disks are available in our system, and then try to create a logical volume out of that disks, and a logical volume of 5 GB, and try to extend the logical volume 1 from 5 GB to 35 GB, and after that we deleted that logical volume, deleted that logical group, volume group, and deleted that physical volume. And we did the same for volume 2 as well. Like we deleted first logical volume, then volume group, and then physical volume. We removed it. So once that is done, our system is back to where it was. Yeah. Now let's go and delete the volumes which we added. This can be achieved via Ansible as well. We can create Ansible playbook for that as well. Probably you can try out. You can try to write playbook for creating the volume group and volume logical volumes and volume group and physical volume also. You can write playbook for that, and you can try to experiment around it. This was manual which we did, but we basically do it via Ansible. In our organization, we do it via Ansible. So you can write Ansible playbook as well. So our system is back to the place where it was in the before. Now let's go and delete the instance as well now. I write a blog around it so that it will be useful for you to do the experiment along with the video. So I'll write a blog for that, and I'll try to post it in my description once it is done. So you can please do it. Yeah, you can please do along with me. You will get a fair understanding of how logical volume works. Logical volumes are basically used to make disk management more flexible compared to traditional partitions, like which we do, right. We create partitions rather than that. It is very flexible way of managing the disks. Um, you can merge multiple volumes into single storage pool and make it easier to manage space. And you can make partitions, and logical volume allows you to expand or shrink storage during downtime. Like without any stoppage or without any stopping of the instance, I was able to upsize the volumes which was available, 5 GB with 35 GB. That's how we can do it. So combining multiple volumes into single volume into a logical volume, we can do it via logical volume manager. Rather than allocating all space at once, we can grow the storage as per our need. Like there's a server with 10 GB, and we have a disk of 10 GB. Rather than allocating entire 10 GB to that server, we can allocate 5 GB at first, and then we can allocate as per the need. We can allocate 6 GB, 7 GB, 8 GB as per the need. So that's how we manage using logical volume manager. It's easily scalable. That's all I want to discuss around it. So this is the complete video on logical volume manager. So this is a complete Linux related video which I have created in this video. So it is related to logical volume manager, a complete concept on logical volume manager. I'll try to add few more Linux related videos similar like this. It's a experimentation which we did, right. So it's a lab testing which we did. You can follow along, and you can do the lab as well along with me, like with the video you can do as well. Yeah, thank you for watching the video. And if you like the video, please, if you really like the video, you can please subscribe to the channel and share it with your friends if you feel it is useful.